Hello guys, this is Jyotishwar. Welcome to my channel Study with Pages. Today in this video we will complete our chapter 1, that is periodic table of chemistry. Today in this video we are going to cover all these topics. First, what is a period? The property trends of elements moving from left to right of a period, and periodic properties that are atomic radius, ionization potential, electron affinity, electron negativity, and metallic and non-metallic character. By this we will complete our chapter 1 of chemistry, that is periodic table. Okay, so first, what are periods? Okay, in our previous video we have already saw that there are 7 periods in a periodic table. Okay, in a modern periodic table there are 7 periods. Okay, in our video I have shown you the modern periodic table, and then in it we saw 7 periods in modern periodic table. Okay, what does a periodic table says? What does period say in periodic table? They are the 7 horizontal rows. Okay, they are the 7 horizontal rows. Okay, period 1 2 3 4 5, in that way there are 7 horizontal rows of element arranged in increasing order. Okay, number of electronic shells of an element says us by periodic table. Let us take an example as hydrogen. Okay, hydrogen is an element of period 1. Okay, so the number of shells in hydrogen are 1. Okay, this is a nucleus of hydrogen. Number of shells, there are 1 shells and 1 electron in its outermost shell. Okay, period 1. So we have hydrogen and helium in period 1, and both of them have only 1 shell. Okay, so the period number says us how many shells are present. Okay, how many shells are present in a element. Okay, how many shells are present in the elements in a period. Let us take an example as period 2. Okay, elements in period 2 are lithium, beryllium, boron, carbon, etc. Okay, so now let's take lithium. Okay, so this is the nucleus of lithium. Okay, lithium is what is the atomic number of lithium? The atomic number of lithium is 3. So let us see, this is the nucleus. There are 2 electrons in its first shell, that is K shell. In its second shell there is one electron. Okay, so total there are 2 shells. Okay, total there are 2 shells in element lithium. It comes under period 2. So uh, period number, okay, period number is equals to number of shells. Okay, this is called a period. Okay, this is an interesting topic and important topic. Please concentrate. Let us take this table for better understanding. Okay, so now you can observe there are period numbers, types of period means it is short, long. Next, number of elements present in period number 1, period 2. Next, atomic numbers. Okay, what are the atomic numbers of elements present in period number 1? Okay, and these are the elements. So let us take an example of period number 1. Here, this is the shortest period of all 7 periods. Why? Because it is having only 2 elements in its period. Okay, that is hydrogen and helium. As it is period number 1, it has only 1 shell. Okay, now coming to period number 2, this is a short but not the shortest. Okay, and it have 8 elements in its outermost, sorry, in 8 electrons in its shells. Okay, and it comes under period 2. All these elements come under period 2, so they have 2 shells. Okay, so they have 2 shells. What are the elements present in period 2? They are lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon. Okay, this is a short. Next, coming to the third one, it is also the short and consisting of 8 elements. Okay, what are the atomic numbers of these 8 elements? They are 11 to 18. What are those? Sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, argon. Okay, now coming to the fourth one, this is the long one. Okay, this is the long. We have completed with short. Now coming to the long, there are 18 elements in it, which atomic number are 19 to 36. Okay, potassium and calcium. Okay, till calcium it is enough for our syllabus. Okay, so now we have understood about periods. Now we will move to property trends of elements from left to right of a period. Okay, what are the property trends of an period moving from left to right? Okay, what are those? There are 2 points. One is similarity and another one is transition. When coming to the similarity, what is the similarity? The similarity is number of electronic shells remain same, as we have already discussed. If let us take an example as period 1. Here you take any element in period 1, the number of shells will be 1. Let us take an example of period 4. You may take any element in period 4, but the number of shells will be 4. Let us take an example as calcium. Calcium has 4 shells and it comes under period number 4. Okay, this is the similarity in period. Now coming to the transition. Here the valence electrons and non-metallic character increases one by one. Okay, so now we have completed with the property trends of elements from left to right of period. Now coming to the periodic properties, which are 5 and important. By this we will complete our chapter 1, that is periodic table. Now first, what is atomic radius? Okay, what is atomic radius? Atomic radius is the distance. Okay, atomic radius is the distance between nucleus of an element to its outermost shell. Okay, you understand? So atomic radius is the distance between nucleus to the outermost shell of an element. Let us take an example as lithium. So this is the nucleus. There are the atomic number of lithium is 3. So in a K shell we are drawing 2 electrons. In L shell we are drawing 1 electron. Okay, so the distance from nucleus to the outermost shell, okay, this is called atomic radius. Okay, I think you understood. The atomic radius is the distance from nucleus to its outermost shell. Now I will tell an important topic. Okay, so you take any of these properties. Okay, out of these 5 you take any of these properties, but there are main 4 points. Okay, first one is term. Okay, first one is term. Now we have already discussed about the term of atomic radius. Now what is the second point? It is factors. Okay, factors which affect atomic size or which affect ionization potential. Okay, so what are the factors affecting these properties? Now third one is trends in atomic size. What are the trends? Trends in any of these property. First one is period. Okay, trends of periods moving from left to right. Okay, and fourth point is trends of groups moving from top to bottom. Okay, top to bottom, left to right. These are the four main properties of, sorry, these are the four main points of these 5 properties. I will explain one by one. Okay, so now we have already discussed about the term of atomic radius. Now moving to the factors affecting atomic radius, what are those? The number of shells increases. Okay, if the number of shells increases, the number of the atomic size also increases. Okay, if now lithium, it is the atomic number is 3, there are 2 shells. Now if I take boron, the size also increases. You understand? So moving the number of shells, okay, the moving number of shells, if the number of shells increases, also the number of the number of size, the atomic size also increases. Okay, that are the factors affecting the atomic size. Now coming to the trends, at trends in atomic size across a period moving from left to right. Okay, what are those? Those are, if the number of shells remain same. Okay, if the number of shells remain same, the atomic size is not affected. But if the nuclear charge is increased, okay, then the atomic size is decreased. Okay, I will show an example. See here, all these elements are of a period 2: lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, and neon. Here, all of these have two shells. Okay, two shells. In it, first shell 2, first shell 2, 2. In that way, all these have two shells. Okay, and its atomic radius is 1.55 Armstrong. Why Armstrong? Because mm, the distance of atomic radius is measured in Armstrong. Okay, it is the unit. Okay, it is the unit of atomic radius. The atomic radius is Armstrong. See. Okay, so example, take lithium. So it is 2 and 1. The atomic radius is 1.55. Beryllium is 2 and 2, 1.12. Okay, this is about trends in atomic size across a period moving from left to right. Now we will see about trends in atomic size from down a group, moving from top to bottom. See here, in a group the number of shells are increasing. Okay, here this is a group 1. Okay, group 1, lithium, sodium, etc. Okay, so here for lithium the atomic radius is 1.5, next 1.91, 2.35. All these are 1.5 Armstrong, 1.91 Armstrong. Okay, here when you look in group, it increases moving from top to bottom. Okay, but when you see in period, moving from left to right, it decreases. Okay, moving from left to right, it decreases. Here they have given that atomic size radii decreases across a period moving from left to right, because the number of shells remains same, but moving from top to bottom, that is in group, the number of shells increases. So absolutely the atomic size also increases. Okay guys, that's it for today. We have completed till atomic radius. All these parts, which are ionization potential, electron affinity, electronegativity, metallic and non-metallic character, we will cover all these topics in our next video. Thank you for watching. Please subscribe and also don't forget to like. Thank you. Bye bye. We will meet in our next video.